Students, in our previous video we have seen about electrical energy, electrical power and power dissipated in a resistor, isn't it? So we have seen that electrical energy. What is electrical energy? Electrical energy is nothing but the work done, isn't it? So electrical energy is the how we can go for electrical energy, as electrical energy is a calculation wherein we will be seeing how much energy is consumed for how much duration of time, isn't it or not? Okay, so that we can calculate the power consumed, isn't it or not? Okay, so how much electrical energy is being supplied for how much duration of time, so that will give us the total energy consumed, or we can go for the calculation of electrical energy, isn't it or not? Okay, so for that reason, we will be going for an equation for electrical energy as E is equal to, or electrical energy is what? It is the energy consumed for so much duration of time, isn't it or not? Electrical energy consumed or electrical energy supplied for so much duration of time, and it is measured as what? E is equal to, that is equal to work or work done, that is equal to P into T, isn't it or not? Okay, so we know that power is nothing but it is what? Work done at particular amount of time, isn't it or not? Okay, so we have rearranged the things, and we have written it so and so. E is equal to, that is equal to your work done, that is both electrical energy and the work done, both means what? Same. Okay, so that is equal to P into T, power into the time or duration, how much amount of time we have, to what duration of time we have used this much amount of power, so that will give us the electrical energy consumed. Okay, fine or not? Okay, so now usually your electrical energy is measured, SI unit is what? Joules, isn't it or not? Okay, so electrical energy SI unit is what? Joules. Usually we won't we will be measuring the electrical energy or energy consumed in terms of what? Watt hours. Watt hours will be measuring. Okay, so watt hours is nothing but your joule only. Okay, so for 1 watt hour, how to calculate 1 watt hour? 1 watt hour in the sense, watt is the unit of hour, and hours or seconds is the unit of what? Time, isn't it or not? Okay, so that is what we have seen here. We will be going for a unit called as watt hour. So in that unit only, we will be going for your consumer, or we can go for the electrical energy calculation. Okay. So this unit will be using watt hour. So 1 watt hour is equal to 1 watt into 1 hour. So that is, watt is unit of power into hour, in the sense seconds is the unit of time. Okay. So 1 watt into 1 hour. So that will be equal to 1 watt into 1 hour is equal to what? 60 minutes. 1 minute equal to what again? 60 seconds, isn't it or not? 60 minutes, and 60 minutes will have what? Each of the minute will have what? 60 seconds. So 60 into 60 seconds. So that will lead to what? 3600 seconds. So that into 1. So that is equal to what? 3600 joules. 3600 joules is equal to what? 1 watt hour. Okay. So instead of writing watt hour, we will be writing what? Capital W and H. So this is the usual our measuring or electrical energy consumed measuring unit. You will be that is actually it is joules. So we will be taking it as what? Your watt hour. Okay. So 1 watt hour is equal to what? 3600 joules. Fine. Okay. Yes. So now when it comes to watt hour or watt second, so when it comes to watt hour or watt seconds, it is very small unit. It is what? It is a very small unit. So that to go for it is very small unit. If we go for such a small unit, it is very tedious to go for our huge calculations and all. Isn't it? But if I go for some grocery shop, and if I go for usually we will be talking about kg, isn't it or not? So if I we will be talking about we want half kg of sugar or half kg of some turda or something like that, isn't it or not? Like that, we'll be talking in terms of kg. We won't say 500 grams, 200 grams, 100 grams. Isn't it or not? Okay. For the things what we'll be buying in a huge quantity, we'll be talking about kgs only. So we'll go to a shop and we'll say 1 kg of sugar I want. You won't say that 1000 grams of sugar we want. Isn't it or not? So the same thing will be going here. Okay. So because watt hour or watt seconds is what very small unit. For that reason, we will be going for a larger unit, what is called kilowatt hour. Fine. So here we will be talking about kilowatt hour. What is kilo? Kilo is nothing but what? 10 power plus 3. Isn't it or not? Okay. Kilo in the sense 10 power plus 3 in the sense what? We are multiplying by 1000. Okay. So 10 power plus 3 means 10 power plus 3 means what? It is nothing but 1000. 1000 in short we will be writing it as what? 10 power plus 3, and we will be calling again writing this, instead of writing this we will be simply taking it as what? Kilo. Okay, yes. So we will be going for kilowatt hour unit, and this is the moderate proper unit to measure the electrical energy consumed. Okay, so we will be going for kilowatt hour. 1 kilowatt hour, it is denoted as what? Small k, capital W and small h. Okay, kilowatt hour it will be denoted as. Okay. So now we will see how much is 1 kilowatt hour. Okay, so how much is 1 kilowatt hour? So now 1 kilowatt hour is equal to 1000 into 1 watt hour. 1 watt hour is what? 3600 joules. Isn't it or not? Okay, so if I do multiply this, so then 1 kilowatt hour will be giving out us the total of 3.6 into 10 power 6. 3.6 into 10 power 6. 10 power 6 is what? Megajoules. Okay. So 10 power 6 means what? Mega. Okay. 1 kilowatt hour is nothing but what? 3.6 into 10 power plus 6 joules, or 3.6 megajoules. Okay. So 3.6 megajoules is nothing but the 1 kilowatt hour. Okay. So 1 kilowatt hour. So we will be defining or we will be measuring our electricity bill, what will be coming after every month to our house. Isn't it or not? Okay. So we can measure the bill. We can measure the bill using this thing. Okay. So usually electrical energy consumed will be measured in terms of what? Kilowatt hours. It will be measured in terms of what? Kilowatt hours, and 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. Fine. So this is how we will be going for kilowatt hour as a unit for measurement of what? Electrical energy electrical energy consumed. Okay. So for example, now how to define 1 kilowatt hour? Okay. So we will see that. What is 1 kilowatt hour? 1 kilowatt hour means what? So it is, so if I have some appliance, or if I have some home appliance or any of the electronic or electrical device it may be, if I have some home appliance like your fridge, TV or whatever it may be. Okay. So if I have that home appliance and it is of how much power rating, or what is power rating, we will see, usually we will see, we will say that what is power rating. Power rating. We will come across this word, what is called power rating. Power rating means what? For a particular appliance or any of the system or any of the device if I take. So power rating is the maximum amount of power, that means what? The amount of power that device actually takes or consumes to operate. Fine. So the amount of energy or amount of power that device takes to get operated. Okay, fine. So that is called power rating, maximum power, or the amount of power that device consumes to get operated. That is called power rating. Usually in fridges and all, like it will be a star rating, power rating. This thing will be there. 5-star rating, 4-star rating, 3-star rating. Okay, so that is all about the power consumption. It will be written over there. Okay, so power rating is what? The amount of power that particular device is consuming. Okay, so that is what power rating. Okay, so if I have some device of 1000 watt of power rating, if I have some device of 1000 watts of power rating, so then 1000 watts is equal to what? 1. It is what? 1000 watts is equal to what? 1 kilowatt. Fine. So 1000 watt is equal to 1 kilowatt. Usually we won't take here because our calculation is in terms of what? Kilowatt hour, because this is being watt hour or watt seconds is what? Very small unit, so we'll be going for kilowatt hour. So it is 1000 watts. Okay, so usually that is the major thing, like 1 kg it is 1000 grams, isn't it? So likewise it is 1000 watts is equal to 1 kilowatt. If I have some appliance of 100 means 1000 watts, that is equal to 1 kilowatt. Okay, so if some device of 1 kilowatt power rating is operated for 1 hour. If it is operated for what? 1 hour of time. If I have 1 kilowatt power rating device or appliance which is operated for 1 hour, so then I can say the energy consumed is what? 1 kilowatt hour. Fine, is that okay? So 1 kilowatt hour is equal to what? It is an appliance of 1 kilowatt power rating of 1000 watts of power rating is operated for 1 hour. Then I can say that electrical energy consumed is what? 1 kilowatt hour. Okay, so electrical energy is consumed can be set as what? 1 kilowatt hour. Is that okay? Is that okay? Fine. So this is how we will be going for calculation of what? The electrical energy consumed, and 1 kilowatt hour is called as what? 1 unit. Okay, in our day-to-day electrical bill consumption, we'll call what? 1 kilowatt hour is called as what? 1 unit. If 1 kilowatt hour of energy is consumed, that means what? 1 unit can be measured. Okay, so it is called as what? 1 kilowatt hour can be said as what? 1 unit. Okay, so usually we will say so many units have become and so much bill has come. Okay, so usually your bill will be in terms of units. Okay, so unit means what? 1 kilowatt hour means what? 1 unit. Is that okay? Fine. 1 kilowatt hour is equal to 1 unit, and 1 kilowatt hour is how much? What is that calculation? If an appliance or any of the device which is having power rating of 1000 watts or 1 kilowatt is operated for 1 hour, so then I can say 1 kilowatt hour is the power or electrical energy consumed. Fine. So it is said as what? Electrical energy consumed will be 1 kilowatt hour, and that is equal to what? 1 unit. So in terms of units we will be calculating, and your bill will be in terms of unit only. So here I can say, for example, I can take any of the example in terms of units. Okay. So if I have some appliance of let us take 2000 watts. I have an appliance of 2000 watts. Okay, I have an appliance of 2000 watts. That means that is equal to what? 2 kilowatt, and it is operated for how much duration? If I say for 3 hours. 3 hours it is operated. Fine. So I have some appliance of 2000 watts, that is equal to 2 kilowatts, is operated for 3 hours, and your rate per unit electrical energy consumption will be calculating. Okay, fine. So rate per unit, if I have this rate per unit, so this will be the thing in your home, electricity bill in terms of units. Okay, so rate per unit, if I say some 4 rupees, rate per unit is 4 rupees. So then how to calculate the electric bill? How to calculate how much rupees is your bill? Okay, so how much rupees you have to pay for this much energy consumption. for 3 hours. Okay, so this is how I can go for. Now it is 2000 watts or 2 kilowatts of power rating appliance. So it is operated for 3 hours. So that means what? If I have 2 kilowatts of like any of the device or any of the home appliance which is of what power rating? 2 kilowatts of power rating, and it is operated for 3 hours. And it is operated for 3 hours. So then I can calculate the total units consumed. Total units consumed by this home appliance when it is operated for 3 hours. Okay, is equal to how much it is? 2 kilowatt hour. Isn't it? Means 2 kilowatt appliance operated for 3 hours. So that is equal to what? 2 into 3 is equal to 6 kilowatt hour. Okay, 6 kilowatt hours. Okay, 6 kilowatt hours. 6 kilowatt hours. That is equal to what? It is 1 unit is equal to 1 kilowatt hour. 6 kilowatt hour is equal to 6 units. Isn't it or not? Okay. So now, what is the cost per unit or rate per unit? Or cost per unit is what? Rate per unit or cost per unit also we can write. Okay. Cost per unit is what? 4 rupees. So my bill will be equal to what? The total energy consumption bill is equal to or total price. Total amount is equal to the total amount what I have to pay will be equal to 6 units into 4 rupees. That is equal to 24 rupees is my electricity bill if it is operated for 3 hours. If some device of 2 kilowatt hour rating, if it is operated for 3 hours and cost per unit is 4 rupees, so then electricity bill for that particular instant only I have used 1 day for 3 hours. Fine. So my electricity bill will come out to be what? 24 rupees. Fine. Is that okay? Correct? Okay. So if I say, if I operate it daily for 30 days, that will give you 1 month bill. This is 1 day bill. Fine. So only for 3 hours I have used this much power rating appliance I have used for only 3 hours. So then I will be calculating the units or kilowatt hours, how much kilowatt hours it is consumed, it has consumed, and that is equal to so much units, and so much units into cost per unit. If I multiply, I will get the total price or total bill. Okay, bill will be getting how much will be your total bill what you have to pay. Okay, to my electricity board. Okay, fine. Now my thing is I have to calculate if this thing happens for 30 days. Okay, 30 days if I have to go for 30 days if I have to go for this appliance will be operated for 3 hours each day for 30 days. So then it will give you 1 month bill. So this into this is for 3 hours. Okay, so 2 kilowatts for 3 hours means that is for 1 day it is 6 kilowatts into 30 if I do I will get it for what? 1 month. Isn't it or not? Okay, 6 into 30. Okay, so you get the result as so and so. Okay, so how much it is? 180 units. Isn't it or not? Okay, it is 180 units. 180 units into 4. If I multiply, so I will get the amount to be so and so rupees. Okay, so it is not 24 rupees. So it is 180 per unit into 4 rupees. I will get so much of rupees as the final answer. Okay, so 180 into 4 if I do, so much rupees will be the 1 month bill. Fine? Yes. So now we will see for some example later over here. So now if I have some 60 watt bulb, so this is not to calculate the power. Okay, it is actually to calculate the current which is flowing and the resistance. Okay, so now our question is like a 60 watt bulb. I have a bulb which is of 60 watt power rating, and that bulb is connected to 220 volts of power supply. I have a power supply. Power supply is what? What is power supply? If this is your bulb which is operated, this will be glowing when it is connected to your AC mains or any of the plug-in. So now this is what power supply. Or if I have some source wherein I will be getting the energy. Okay, so power supply, or it is nothing but, what is power supply? Power supply is something, or it is a device which supplies power to the what is that? Any of the device which has to be given some energy to make it operate. Okay, so I have a bulb. So this is the load. Now it is what? Load. This is load. Bulb is our load. So this is the device which has to operate, and it has to be given some energy, or it has to be given some voltage. Because of that voltage, current starts to flow. I have to give some voltage, because of which current starts to flow. Together, voltage and current is what? Power. P is equal to V into I. We say it as, isn't it or not? Power is equal to voltage into current. How much voltage you have applied, how much current is flowing. That product is your power in terms of watts. Okay, and now power supply. It is the source from where the power is supplied to the load. Okay, so this is what's power supply. Fine, is that okay? So now our power supply is what? Power supply is what? 220 volts. Okay, 220 volts of voltage they have given, and that bulb, this bulb consumes 60 watts of power. This bulb consumes 60 watts of power, and that power supply what I have given is what? 220 volts of voltage, and some current flows through it. Okay, so our question is to calculate the current flowing through the bulb. How much current is flowing through the bulb, and also the resistance of the bulb. So I have a device, that means what? It will have, this is load, isn't it? So this load is nothing but what? It will be having some resistance I. So what is that resistance is our question. Okay, so I have a bulb. So any of the device which when it is there, so that means what? It will have, definitely it will have what? A thing called resistance. Fine or not? Okay, so you have anything, so that will have what? Any of the device you can take, it will have a common property called resistance. So the power, or it is the property of certain material or any of the material to oppose the current flow. Okay, so to oppose the current flow, so that is what is called resistance. All of the devices will have certain resistance for sure. Okay, so now this bulb will be having certain resistance, and our question is also to calculate the resistance too. Okay, so I have to calculate current also, and also the resistance. Fine. Yes. So now here our things given are what? Solution we will go for. Things given are what? Power they have given 60 watts. Okay, so the bulb has got power rating of what? 60 watts, and voltage is what? Applied voltage is what? 220 volts. So I should calculate I, and I should calculate resistance R. Okay, so we know that power is equal to P is equal to V into I. So in this formula, I can rearrange the things. I can calculate I, isn't it or not? When I know I, when I know power and voltage, I can calculate current. I is equal to P divided by V. P divided by V, if I do, it is 60 divided by 220. If I do, I get the answer to be what? 0.2727 amperes. 0.2727 amperes will be the current which will be coming as a result. Okay, so I have what is that current which will be flowing? It is 0.2727 amperes of current will be flowing through the bulb. And now to calculate second part, we will be going for calculation of the second part. So resistance of the bulb I have to calculate by from Ohm's law. You know that V is equal to I into R, and I know V V and I. So I will calculate R. Isn't it? I will realize the things. R is equal to V divided by I. Okay, R is equal to V divided by I. So that is equal to what? It is 220 volts divided by the current is what? 0.2727. If I do, I will get the resistance to be equal to 806.75 ohms. Okay, 806.75 ohms of resistance will be getting. Fine. So this is one of the examples what you can go for calculate the current and resistance of certain device when the power has been given and the voltage, power supply voltage has been given. Fine. Yes. So this is all about your electrical energy and electrical bill calculation, and also one example where we can calculate the current and resistance of some bulb or anything it may be. Okay, if they have given current, we can calculate voltage of the power supply. That also can be done. Okay, so when I know the current which is flowing, you know, and the power rating if you know, so that you can calculate the voltage. Okay, so that also be another type of question. Fine. Now we have a question to find the total resistance between A and B. So here we have a network, or we have a circuit wherein different 1, 2, 3, 4, 5, 5, and we can have another resistance here R. Okay, like 6 resistances we have in this circuit. So now our question is to find the total resistance between point A and B. So we have a circuit given and we have 6 of the resistances connected here, and our question is to find the total resistance between point A and point B. So we have 2 points A and B. So I have to find the total resistance between point A and B. So this is our question. Fine. So now our first thing is to solve this network or this circuit into a simpler circuit. Fine. Okay. So that is our intention now. So now here the circuit has been given in a manner so that we will now we have a confusion in our mind. So how to solve this, isn't it? So here now we have to go for the series and parallel combinations. So we have to see what all resistances will come in series and what all resistances will come in parallel to each other. Okay, so that we have to see first. So now considering from this side, from A we will see, or that side also we can consider, no problem. Okay, so here we will see from this end. So here I can, so all of the resistances are of same resistance. Okay, so all the resistances are of same resistance, that is equal to R ohms. R ohms of resistance, all of the resistance have got. R ohms of resistance they have got, so they haven't given any value, so simply they have mentioned it as what R. So resistance of R ohms, some imaginary resistance we take, and it is understood that all of the resistance value is same. Fine. Yes. So now here we will see at this point. Okay, so if I see, so this resistance R here and another resistance R. So here you can see whether they are in series or parallel. I can calculate, I can find out whether they are in series or parallel. Okay, parallel combination is what? One end of this resistor should be connected to one end of two of the ends, or I can say I have one resistance R, another resistance R. Both the ends of this resistance, if it is connected to both the ends of the other resistances, other resistance, so then I can say these two resistors are connected in parallel, isn't it? So both the ends of one resistor is connected to both the ends of the other resistor, so then both are said to be in parallel combination, isn't it? Yes. So in the same way here I can see, so this end of this resistor is connected to this end of this resistor, and this end of this resistor is connected to again this end of this resistor. Fine. So then I can simplify this as what? This R is in parallel with this. In the same way here we have from this end, if I see, so this end of this resistor is connected to this end, and this other two ends are connected again at the same point. Fine. So now these two are again in parallel. So I can reduce this network in this fashion. Okay. So I can reduce this network in this type, like in this manner, so that here there is a confusion in understanding. Here we have clear understanding. Fine. So here this is our point A, this is our point B. So now this R is in parallel with this. So here clearly I can see. So above, like upper, two ends are connected together. Lower, two ends are connected together. Here also upper ends are connected together. Lower ends are connected together. So now this R is in parallel with this. This R is in parallel with this. So first we have to solve these R parallel combinations. Then we will go further. Okay. So now to solve these two things. So this resistance R is in parallel with this resistance. So when it comes to parallel combination, when R is in parallel, so these two lines, okay, so two straight lines or vertical lines will represent what? Parallel combination. To represent parallel combination, we will use two vertical lines. So R is in parallel with another R resistance. So the total resistance or effective resistance when R is in parallel with R will be equal to R by 2. So how it is going to happen? How it is going to happen with what? So total resistance, parallel resistance. Okay. So when this R is in parallel with another resistance R, so when it comes to parallel combination, I can go for the total resistance as what? 1 divided by Rp is equal to, or effective resistance is equal to 1 divided by R plus 1 divided by R. When both the resistances are equal, that means what? It is R and R. So I can take it as what? It is R as common I can take. It is 1 plus 1, that is equal to 2 by R. So it is 1 by Rp is equal to 2 by R. So what is Rp? Rp is equal to R by 2. So Rp is equal to what? R by 2. Or nothing but R by 2. So when I have this R is in parallel with R, the equivalent resistance is equal to what? R by 2. So now I can reduce. Now I can reduce this network like this, so that both the resistances are in parallel. That means I can combine them to make one resistance, that is equal to R by 2 resistance value. Fine. So it is R by 2 resistance. Again this is what? Again R by 2 resistance here. So now this is point A. Again I have like simplified the network from this to this, isn't it? So now it is R by 2. R by 2, here we have R and R resistances between point A and point B. So now when it comes to this thing, so I can see now again further solution, like further reduction of the network we can go for. Now parallel things are done, isn't it? So now we can see, so here this resistance R resistance R is like if I see this end from A point, if I see, so now this resistance 1 and is connected to the one end of this resistance, and this resistance the other end is connected somewhere to point B, isn't it? Alright. So now these and these two resistances are in what? Series. And again in the same way these 2 points between A and B point, these two are in again series. These two are in series. These two are in series. Separate. Okay. So again these two are in series. So these two resistances are in series. Okay. At between point A and B, and these two resistances are again in series between point A and B. So I can reduce them again to make what? Now what is R by 2? So what is that? R by 2 plus R. How I can make this? This will be coming out to be what? It is, if I do this, then both the resistances are in series. So total resistance is equal to what? This resistance plus this resistance, isn't it? Okay. So total resistance RS is equal to first resistance plus second resistance. If I go for the solution, so if I have to take RS common, it is what? R plus 2R is equal to what? It is 3R by 2 is the total resistance, isn't it? So now I can make a simplification of this circuit as what? So I can reduce this in this way, and I can write this circuit in a simplified manner, so and so that this resistance, this equivalent resistance is equal to what? 3R by 2. Again this equivalent resistance is equal to again 3R by 2. So now 3R by 2 and 3R by 2, two two resistances are in parallel between point A and B. Point A and B, in between point A and B. Now this resistance 3R by 2 is in parallel to 3R by 2. How? Because two ends of this resistance is connected to the corresponding two ends of the other resistance. Okay, so both the ends are connected to both the ends of this resistance. So these two are in parallel. So looking at the diagram only, you can see whether they are in series or parallel, isn't it? Okay, yes. So now these two are in parallel. Again, I can go for further simplification of this network as what? When I solve this, so I get what? The total resistance is what? 3R by 4. Okay, 3R by 4, I will get it as. Okay, so how it is? So again, it is 1 by R2 is equal to the thing I have to take. Okay, so it is 1 by RT is equal to what? 1 divided by 3R by 2 plus 1 divided by 3R by 2. If I have to go for this solution, if I have to go for, if I take the reciprocal of that, RT is equal to what? It is what? What it is. Okay, so this is going to be the reversal of that, isn't it or not? So it will result to be what? 3R by 4 will be coming, and the total resistance between point A and B will be equal to what? It is 3R by 4. Fine? Is that the thing? Yes. So in this way, we can go for the solution to find the total resistance between point A and B. In this way, we have to solve it. Okay. So this is one of the important questions. Okay. So what we have to remember properly, they have to see for the series and parallel combinations, and they have to go for an idea how to solve the circuit in a proper manner. Okay. Yes. So now again also I can go for another example where I can see in a man like that. I'll go for another example where I can see three of the resistances connected somewhat like this, point A and B. If I go for, now if I write somewhat like this, and this is R, this is R, this is R. All the three resistances are in R ohms of resistance. Okay, so equal resistances they have. So now this is another circuit. Now how to solve this circuit? How to solve this circuit and how to make out these resistances are in series or parallel, or how to simplify the circuit is our question. Okay, so now to solve this circuit, so we can go for an idea where between A and B I have to find the total resistance. Okay, so then like this is somewhat confusing, isn't it? So this and where is series combination, where is parallel combination is our big hack, isn't it? Yes. So now clearly we have to observe this circuit. Okay, so here I can see from this end. Okay, this is point A, isn't it? So this is point A. So this point A goes here to this resistance, and this point again there is a short. There is a short means I have connected a wire from here to here, isn't it? I have connected a wire from here to here. That means what? This is point A. So this wire goes here and it touches here. This what? This is also point A. Correct or not? This is also point A only. Fine. Correct or not? So this is point A and a wire goes from here to here. That means what? This is touching here. So that means what? This is point A. This is also point A only. Fine. Yes. Likewise, this is point B. This wire, there is a wire or there is a short from here to here. So that's why this is point B. This is also point B only. Correct or not? Okay. So point B is here. Point B is also here. Point A is here. Point A is also here. So that means what? So I can rearrange the resistances and I can have the thing in our mind so that now I can see how these resistances are connected between point A and B. So now here I can see this resistance. To this end it has got A as point, and to this end it has got a point called as B. Okay, so here I have point A, and to this end I have got point B. Fine. Again, to this resistance, here in this side I have resistance, means at this end I have point A, and at this end I have point B. And to coming to this resistance, this end I have point A, this end I have point B. So that means what? All the three resistances will come between point A and B. Correct or not? Okay. So one end we have point A, another end we have point B. Here also one end A, point A, one end point B. Here also one end point A, one end point B across like this resistance. Fine? Yes. So in that manner I can solve this resistance like this circuit like this. Here I have this is point A, this is point B. I can have this resistance R and so and so. Now all the resistances are what? Parallel. Fine? Correct or not? Okay. So this is your resistance. One end is point A, another end is point B. This is another resistance. One end is point A, another end is point B. I have connected it in other manner. Okay. So if I go like this or the other way, resistance is all same. Fine. So I have some resistance. Okay. So I have some resistance. If I go this side, it will show the same resistance. If I go this side also, it will show the same resistance only. Okay. Resistance is the property which opposes the flow of electric current. Okay. So it doesn't matter in which direction you are coming. Fine. So both the directions it will be showing same resistance only. Okay. So that is how we have to make sure in our mind. So resistance is the property which opposes the flow of electric current both the directions. It means same. Fine. Yes. So now this end is point A, this end is point B. If I reverse it, like it is coming to be same. Or if I connect it like this also, no problem at all. Okay. Yes. Because it is showing the same resistance, isn't it? Yes. So now again it is point A, point B. This resistor, all the three resistances are in parallel. Now I can solve them as what? 1 by R1 plus 1 by R plus 1 by R plus 1 by R. It is, I will remember what? It is 1 by RP is equal to total resistance. I can find out it as what? It is equal to 1 by R plus 1 by R plus 1 by R. It is nothing but what? It is equal to R is common, that is 3R, 3 by R. It is 1 by RP is 3 by R. That is RP is equal to what now? RP is equal to, it is R by 3. RP is equal to R by 3. Fine? Yes. So likewise, we have to go for. Okay. So likewise, we can solve this circuit. Fine? Yes. This is all about today's class. Thank you.